one. We will see now mechanism for allylic bromination. Okay, so initiation, propagation in propagation, there are two different steps, and here is the termination stage. Okay, so first one, initiation. Okay, Br2, we are doing bromination with Br2. Okay, bromination of benzylic methyl group. So that one we will do first. Bromine, how Br2 will add as a by free radical mechanism to the benzylic methyl group. Okay, that one we do. Free radical mechanism, first initiation of Br radical, counting total number of electrons is 7, so it's incomplete octet, so that's why is electron deficient, and it's always it's in search for the remaining or lacking, that lack electron, he is always in search for that one. Okay, that's why it's a unreactive intermediates, highly unstable intermediates. Okay, so as it's highly unstable, we can react this one with our desired molecule to react. As this one is highly reactive, it will react very easily. Okay, so pay attention how the radical reactions you have to represent, and in that way you have to. So which bond is forming, which bond is breaking, everything they have given here. BRH, that bond is forming. Okay, so the radical Br dot radical, that is abstract H dot, and H dot is getting the formation of covalent bond, and we do generate here the benzylic radical. So this is propagation stage, this is first stage. What will happen in second stage? In second stage, again another brom Br2 molecule, these generated this free radical, stable free radical, I am telling stable free radical, that one is, that means now this one acts as an initiator, that one abstracts Br dot, and in this way there is a bromination of this benzylic radical, and this which bond is forming, carbon bromine bond is forming, and which bond is breaking, so bromine bond is breaking. Okay, here is one R is missing. Okay, this is the propagation number, second stage. And finally termination stage. Termination is the same thing, termination CH2 Br formation, that is the termination. For example, this is only one kind of termination stage. Maybe here, as we have seen in last lecture, this another molecule of this benzylic radical, they can also join together and they can form molecules. That is also one termination stage. Bromine radical, one bromine radical can react with another bromine radical forming Br2. Again, this one is also one termination stage. Okay, so and this benzylic, two benzyl radical, that is dimerization also can occur of this benzylic radical. So this is also termination stage. Okay, so pay attention, termination stage, it could be any free radical, they can attach together and they can reaction can terminate. Okay, so what was the explanation for benzylic bromination? Mechanism will start from after initiation by heat or light, bromine radical. Who is coming and going always? Who is there? Always there is some sound. Okay, so pay attention. Once you are entering, no, don't come and go. Okay, everything is getting recorded in your that presentation sheet, and those presentation I have to submit somewhere. Okay, so at what time you are coming, at what time you are leaving, everything is getting recorded here. So try to stable in first 2-3 lectures also I have told, wherever you have range, go and sit there at that place. Okay, it's almost now 24 minutes by starting lecture. Still you guys are coming and leaving the classroom. Okay, next one here. Mechanism. When we are to regenerate bromine radical, thus these two shall repeat until the concentration of Br2 runs low. See, these things, this line is very important because whenever you are doing reactions in our laboratory, if you might be, you didn't pay attention at that time, you are taking normally 1:1 mole reagent. Okay, if you are going to add two starting materials, then normally you are weighing materials on weighing pan, and then you are adding your beaker. Whenever you are doing any preparation, you didn't pay attention at that time. If you are weighing one substance maybe 2 gram, another substance maybe 150 milligram. Okay, 200 milligram, 150 milligram. Okay, so these all these things procedures, they are developed on the basis of, if you are adding 1 mole of bromine, then you have to add 1 mole of olefin. Okay, so these 2 moles, one has 1 mole of bromine, 1 mole of olefin, they will react with each other, and then there is a formation of product. If you will add 2 mole of bromine and 5 mole of another starting material, then it won't react. Another starting material will remain as it is in your flask. Okay, so here is the thing, that you have to add the proper ratio of both these starting materials, then only you will get 100% yield. You are calculating yield also at the end of your practical exams, practical after you are finishing experiments. So okay, so at that time you are weighing those things. No, that one has developed on the basis of, okay, this 1 mole of bromine, this will weight this is, because every molecule will have different molecular weight. Okay, we have to decide that on the basis of molecular weight. Okay, this much 1 mole means this much gram we have to take starting material 1, and starting material second one, on the basis of molecular weight we have to weigh this amount. Okay, so always remember, two starting materials if you are adding, you have to take those in 1:1 equivalent ratio, should be 1:1. Then only every molecule of one first starting material will react with the another every molecule of the second starting material. Okay, if you will add too much, then there is a, you will get product, but that one it's too much with impurity. Starting material will be there, and your TLC is also showing your TLC. When you are taking TLC, that one is also showing your starting material. Okay, so this is not very good idea. So whenever these reactions what we are studying now, these everything is depend on different reaction ratios. Okay, all different group of researchers, they have tried all these reactions. So we have to pay more attention on how much mole of bromine and how much mole of olefins we have to add, and then how the bromination occurs on the benzylic ring. Okay, there are so many different factors we have to pay attention. Now next we will go for bromination of allylic group. Okay, so allylic methyl group here. Now the thing is, Br2, I am talking Br2. Okay, bromination. In previous slide we have done bromination of benzylic methyl group. Okay, so now here also we will use same Br2 for the allylic bromination. Okay, but here we have seen that for allylic bromination, Br2 is not an appropriate reagent. Okay, the heading is Br2 is not an appropriate reagent for the allylic bromination. Okay, so we are getting product as actual product is dibromination, and decide what we want to do, where at which position we want to do bromination. So at methyl group we want to do the bromination. Okay, so that one we are not getting by using Br2. Okay, so okay, what to do now? Okay, so we are getting vicinal dibromides, which we don't want. So what we have to search for some different solutions. Okay, so research is nothing but we have to always search for different solutions. There are plenty of things available in organic chemistry. That is the beauty of organic chemistry. So we can try even thousands of different brominating reagents to carry out to get this desired product. We have to change this reagent. Br2 we don't need, and Br2 actually is cheap. Okay, cheaply available, so we can take that bromine solution or anything. We can add just 1 drop of bromine solution, a concentrated bromine solution, and you will definitely suddenly you are, that is totally, it's too reactive. So it's react suddenly with this carbon-carbon double bond, and that one is giving dibromide product. Also, this is very quick reaction with concentrated. This is concentrated bromine. Okay, so Br2, if we will add 1 drop here. Okay, so we cannot say 1 drop. We have to go with weighing solvent, with molecular weight. We have to calculate of this starting material, molecular weight of this Br2, and with the calculation of molecular weight, we have to go for 1 mole of this one and 1 mole of Br2 we have to add, and then we have to do the reaction. Okay, then all moles of Br2 and all moles of this with allylic methyl group, they will react with each other. You are getting the product, but product will be this one. Okay, so we have to avoid this Br2 because we don't need dibromide products. Okay, next one. Now alkenes reacts with Br2 to form vicinal dibromides as a product by bromonium ion. Okay, so this product, dibromide product, we are getting by bromonium ion. 3-membered ring is forming 3-membered positive carbocation. Bromonium ion positive charge is placed on bromine, and that with that mechanism, but not allylic bromide. We are not getting allylic bromide. So how we are getting, what is the mechanism? So we are getting this dibromide product by this mechanism. Okay, this is bromonium ion mechanism. So carbon carbon double bond is going to react with the Br2 in this way, and so this is the very quick formation of bromonium ion. This is unstable intermediate bromonium ion, 3-membered ring with bromine. It's very unstable, 2-stranded ring. This cyclopropane ring is very strange, so that one is getting open, cyclobromonium ring, and this is suddenly that one is getting open, and you are getting this dibromide product. So but we don't need this dibromide product. Alkyl reacts with Br2 to form vicinal dibromides, not allylic bromides. So we don't need this type of mechanism. We are studying free radical mechanism, and this is not free radical mechanism. Okay, so now we have to think on the free radical mechanism, and we want to change. We want to change this. We don't want 2 bromine atom. We want only 1 bromine atom. Okay, so we want to add only 1 bromine atom, and that one is not possible by this type of addition reaction. This is addition reaction to carbon carbon double bond, but not free radical addition reaction. This is another kind of addition reaction, and we want to study free radical addition reaction. Okay, so we will go for now free radical addition reaction. This is not free radical addition reaction. So what will be the solution for this problem? Okay, so how to avoid the dibromo product, how to get the monobromo product. Okay, and how to increase the selectivity of the product. Okay, so now we have now I have told you that we always add 1 equivalent of bromine and 1 equivalent of your olefin. Okay, then we have to add together these 2 moles, and we have to keep for reaction. So 1 equivalent of bromine will react with the another equivalent of your starting material olefin, whatever allylic group, and these 2 react. If we will increase the bromine again, then again the situation will get worst. Okay, if we will decrease bromine from 1 equivalent to 0.5 equivalent, that means just we will reduce the amount of bromine, then also then also it won't make any sense. Okay, so only by decreasing or increasing bromine in solvent system, it won't solve the problem. Okay, so anything you will use by bromine, that Br2 solution, it won't help us out. Okay, radical substitution over, we have to think about for the radical substitution over the dibromination. So we normally Br2 adds to olefin, it's addition reaction, and we don't have to add, we have to do substitution. That means CH bond we want to abstract, CH bond we have to cleave homolytically, and we want to substitute that hydrogen with Br, only 1 bromine atom. Okay, so for that one we have to think. So we have to go for substitution reaction, not for the addition reaction. Okay, so it's a substitution reaction. Now if we will go for very low concentration of bromine, Br2, that means I have told from 1 equivalent, if we will reduce 0.5 equivalent, concentration of bromine is kept low. Not only will rate of diamorphism will be lower, the relative concentration of bromine radical related to Br2 will increase. Okay, now this one we will understand on your next slide. Rate of CS abstraction. Okay, we will not understand. We will go for the thing. How to do that one? So we can avoid the dibromination to the carbon-carbon double bond. Okay, we can avoid that one by using different reagent like N-bromosuccinimide. Okay, so in N-bromosuccinimide, if you observe the structure of N-bromosuccinimide, you can see only one bromine is attached to the nitrogen. So obviously the only one Br is present. The thing is the Br is detaching from here, and that one is getting add to the molecule. But how that one is generated? So this kind of Br2 molecule is getting generated in situ of the reaction, and this Br2 will react with the further your carbon-carbon double bond containing your starting material like methyl or methylene group. Okay, with that one, this generated Br2 is reacting via free radical mechanism. Okay, this is one kind of. So the we have to replace Br2 with the N-bromosuccinimide, and by using N-bromosuccinimide we do generate Br2 in situ of the reaction. So okay, in Br2 reaction is generating in between, but if you will pay attention, the concentration of this Br2 whatever getting prepared in that flask. Okay, so this concentration might be very low. Okay, so instead of adding Br2 directly, if we will add Br2 is very reactive. It's it's a very reactive substance, Br2 bromine, and whatever we are generating from this Br2 from this one is